have kind of like issues looking at it, or is it good to go?
No, we see it.
Cool. All right, I'll just kind of start off. So we'll kind of introduce the board first before we get into the presentation. I'm Richard Chavez. I'm the president for this year for ASME. If you, a little bit about me is I'm a fifth year mechanical engineering student, and I'm very thankful that a lot of you guys showed up. I see some familiar faces. I see some new faces. And I mean, given our current situation, it's kind of weird kind of meeting through this, but I'm glad you guys make the time and effort to show up. What we really do here is a lot of robotics work. So we're currently in a competition. Um, Whether or not that competition is going to happen this year is kind of like still up in the air. But we're still working on the actual task itself. So we can get a little bit more into that. But just in terms of that, I just kind of wanted to thank everybody for showing up to the first general meeting of the semester. So thank you. Do you guys want to introduce yourselves?
Oh, sure. So my name is Gary, fourth year mechanical engineering student at Castile. Of course, at Castile. Where else? But um, I've been, some of my background is in robotics, so I've done some research with Dr. Shen in the past. In addition to that, I've been with the SMU for about 3 years. First as treasurer, then I became president, and now I'm electrical lead. Yeah. So if you haven't, this year I'm in a senior design team for Baja, so which is completely different from all the robotics related stuff that I've done in the past, which is good for me because I was trying to expand. Yeah. So if you have any questions about, my, I guess, any experience that I have, feel free to ask me.
All right, cool. My name is Jovan. I'm a I'm a third year ME student. I've been part of ASME for about a year now, and currently I'm secretary. And that's about it.
Hello there. My name's Abel. We're at the table. I'm a second year mechanical engineering major, and I am the treasurer of ASME. So yeah, I'm mostly handling with the money stuff, even in this current crisis. But don't worry, I play Monopoly, so I'm kind of an expert. And yeah.
Not gonna lie, I thought you said prices, not crisis.
Both, man.
That's Abel.
All right. So my name is Tim. I am the mechanical team lead this year for ASME. So it's my 4th year here, but I'm considered a junior, so I'm not ready to graduate like Gary. I've been a part of ASME since my freshman year, so 3+ years now. And yeah, I'm ready to help you guys learn about what the mechanical team does.
Thank you, Tim. So now you want to.
Hold on. Hi, I'm Sandra. I'm an event coordinator for ASME. I'm a 4th year computer science major, and this is my 2nd year in ASME. I guess something else is I run like the social media kind of. So if you guys are ever messaging, it's me.
All right, I guess I'm last then. Hey everybody, my name's Oren.
Hi, Oren.
Hey Gonza. I'm a 2nd year mechanical engineer, and it's my 2nd year in the club. For this year, I'm the computer science lead. I'm also, another thing I do, I'm the vice president of RoboSub, and I'll be leading like the computer science stuff over there. So for those of you that have been coming to the workshops, you already know that like everything is kind of going to be joint between the two clubs for the computer science side. And yeah, and like Gary, I've also done some research with Dr. Shen.
All right. Thank you. Yeah, that's our board for this upcoming year. I guess we kind of made some slides up to just kind of inform you guys what's going to be going on like this semester. So if you guys can just kind of listen, we'll give you guys more of an insight as to what we do. So can you go to the next slide? Yeah. So this year we've been a part of this competition called the Intelligent Ground Vehicle Competition. It's an autonomous competition where we have to create like a robot that has to navigate itself through a course. It's very intuitive. There's a lot of like moving parts to it, but I guess the biggest thing is that it's autonomous, which means that it's self-operated. It's kind of different from the traditional competitions that we do, which are more so remote control based. So that requires a lot of CS work. And yes, I mean, our name is American Society of Mechanical Engineers, but I mean, for this competition, we have to kind of dig deep into that CS background. But luckily, we have Sindel, so she's a big help, as well as like Aaron. So I guess the best thing I can say is don't be scared to move out of like your major if you're an ME. I mean, make sure to kind of like go another direction like CS. Aaron's an ME, but he's been working heavily on the CS side. So it's just kind of something that we've been doing. And this competition, I mean, we were set to compete last year before kind of like quarantine hit. But once it hit, we were like in the testing phase, which is where we left off. And that's where we're trying to pick up currently. Something I do want to note is we're like in the process of getting the parts out of the lab so we could bring them home and work on them. That's obviously the goal, is to finish and hopefully compete this year if everything is better. But the main goal is to finish building this and have it all function. So I just kind of want to throw that out just in case you guys were thinking this was just going to be virtual. It's going to be partial virtual, and then we'll actually have to like work on it together. You know, obviously safety first, but just kind of want to bring that point up just in case you guys were thinking that this wasn't going to be hands-on. So thank you. Does anyone else have like something to add to it? All right. I guess not. I guess we're good. We could go to the next slides. Next slides are just going to be our leads talking about like their respected sub teams. So I'll just leave that one off to Tim and the rest of the sub team leads.
Okay, so I'll talk about the ME team. So the ME team is responsible for designing, analyzing, and creating all aspects of the required mechanisms and mechanical systems needed for the robot. So if you're interested in learning how to design mechanisms with CAD, perform stress, frame torque, and dynamic analysis, or like hands-on work and machining, this team's for you. So far the tasks that we have so far is the chassis design / redesign. So it's basically like we have our chassis now, and we kind of want to redesign it using the old parts. And I kind of want the ME team to do that. So there's a couple things to keep in mind when designing your own chassis. You have to take into account certain constraints, such as the size and weight of the battery, the payload, the electronics compartment, motor placement, and it has to follow the rules pretty much, which means that it has a minimum width and length, and it needs to be waterproof. So stuff like that. And then number 2, we have vehicle dynamics analysis. This is kind of like a broad term for the robot. So we have to consider certain forces, such as like rolling resistance, grade resistance, and other forces like that to calculate how much torque is needed to drive the robot. And some other calculations such as like the turning radius, which is dependent on how fast the wheel is spinning and the distance between the motors. So these calculations are going to be based off of the chosen iteration. And then next we have a vibration dampener for the camera and LiDAR if we need it. So right now there's like 2 ways you can dampen vibration, mechanically and digitally. So depending on whether we can digitally dampen the camera, or if we even need it, the mechanical team will need to design and build a vibration dampening system or a 2-axis gimbal, for example. And yeah, I think I highly encourage the ME team to try out the other teams as well, so they can understand their scope and how it relates to the design portion. So yeah. All right, I'll hand it off to Gary.
Hey guys, thanks for unmuting me, whoever that was. Yeah, okay. Anyways, so basically the EE team is primarily responsible for making sure that all the electronics are powered up and as well as functional. In addition to that, we also need to implement safety features like putting fuses to make sure that you know, whenever the motor kind of like draws too much current, we can stop it from before the wire gets too hot and like basically burn up, things like that. But of course, if you're looking for, like, so some of the things that you're looking forward to, such as like learning how to solder, design circuits, and some low-level coding experiences, CS goes into really hard, kind of advanced level. But if you're still not sure if you want to do that, the E team also does some low-level coding as well, like Arduino, for example, because some of the tasks does require it. Speaking of task, there's 3 in our team. The first one is a remote controller. This is primarily kind of bridging the gap between basically like allowing the mechanical to kind of test the rover before we even implemented the autonomous side of it. So like how well they'll perform like on an incline and things like that. So we can remotely control and see how it performs before we even have to worry about the CS side, right? So that remote controller will also have like some sort of a feedback monitor on the front, most likely just gonna be like 3 or 4 digit numbers, and those digit numbers can be either be data of like how much battery life is left, or how much or what kind of speed the robot is going at, and yeah, so that's some of the things that the remote controller will we have to implement into it, and after that, next we have a power distribution system. That is a must that needs to get done no matter what this year. That's the focus. Essentially, we're making sure that basically this is the primary mission, which is making sure that every single part of the electronics are powered up, and we don't have any issues. Because last year we tried to finish this task, but we almost got it through. We got into a predicament where we thought we needed 2 batteries. So this year we're going in the other direction of making sure that we only stick with 1 battery, and we already picked out that battery. But now we just need to basically distribute those distribute that power to every single electronics. And lastly, we need to make an electronic mechanical and electrical switch. This is primarily for the competition, because in the rules it says that we need to implement this in case we end up crashing into something, so the judge can easily use one of our remote controllers to kind of switch off the robot. In case of something happens, it has to be wireless and also mechanical, means there has to be a physical button on the robot. In addition to that, there needs to be a wireless controller that also can turn off the robot from afar. But yeah, so those are the 3 things that we are looking that we're going to be doing this year. So if you're really interested in any of the tasks that I just mentioned, please reach out to us and we'll get you guys started. Now, Do you guys have any questions?
When
Well,
you
I
say
gotta-
vehicle, you can go first.
No. You can go first.
All right, Abel. When you say vehicle dynamics analysis, this is because I'm taking statics, I ask. That means
Yeah.
in motion, right? That's when acceleration is non-zero.
Yeah. Yeah. So the dynamics portion of that, it's like, it's like after statics, right?
Yeah.
But we can still apply some statics applications here as well.
Right, because like you want the frame, like statics is when like you want the frame to be actually solid, and
Yeah,
dynamics is when you want to like analyze how it's gonna like move across this terrain and whatnot.
Yeah, exactly.
Thank you very much.
Abel, you gonna say?
Yeah,
Abel, your catchphrase.
Yeah.
yeah. I was just gonna say that. Hey, if you guys join the EE team, it's gonna be pretty electrifying.
You know what's funny? When I was preparing the slide, I was gonna put shocking on the description. I think Tim saw it too, but I was like, no, I shouldn't do that, so I took it off. But yeah. Anyway, if you guys don't have any questions, I'm gonna hand it off to Aaron. All right.
Yeah, okay. We'll have time for questions at the end as well, in case anybody's typing or thinking about it or something. Yeah, but hey, again, by talking about the CS team, first of all, did anybody get my joke at the top, or is it just me?
There was a joke.
Yeah, at the
Get
top
it.
of the CS one.
Let me
It's
see.
just you, Aaron, because I didn't even get it.
Nah, at least Sama got it. Yeah, I got
I
one person.
did.
Dude,
The
it's a CS
CS
thing.
CS people get it, yeah. All right, anyway. So the CS team is responsible for doing almost all of the programming on the robot and making it basically completely autonomous. That means after we upload the code and we unplug it, it does everything on its own, and we don't give it any, like, we don't have a remote that says go forward or anything. It just thinks on its own. Yeah, so we're going to be programming, gathering data from all of the sensors. We have the IMU, the LiDAR, GPS, encoders, cameras, all the different sensors we're going to get data from. We'll be running computer vision and state machine on ROS, which is a robot operating system, and that goes into Linux or in Ubuntu. And all of our programming is done in either Arduino or Python, those two languages. Yeah, and if you want to work on the brain of the robot, then this is the team for you. We have 4 main tasks that we're going to be doing. The first one is workshops, obviously. So this entire first semester is going to be workshops this Friday, so in 2 days, where we'll be having the workshop on downloading Ubuntu and using Linux, so like the basic commands and getting Ubuntu on your laptop. So that's really important. If you want to be on the CS team, you're going to have to, if you want to do like the higher level coding, you're going to need to get Ubuntu. If not, you can still use Arduino, but if you want to get to the higher level stuff, you'll definitely need Ubuntu. And so far we've done 2 workshops, 2 Arduino workshops, and those are both uploaded to YouTube. If you search up ASME's YouTube channel, you can find both of them there, and you can watch those if you want to get caught up. Yeah, and we'll be having like ROS and state machine and computer vision workshops in the coming weeks. Yeah, second task is obviously designing and coding the state machine. The state machine is kind of the, it's basically the brain of the robot. So you'll have different states it can be in. So like one state would be looking for a lane. So the cameras are doing their computer vision and they're looking to see if there is a lane. And then whenever you detect a lane, you move on to another state, and that's like turning and making sure you're staying within the lanes and moving forward, and so on. And third task is computer vision. Obviously, that's one of the most important parts of this entire competition, is getting computer vision to work. So being able to detect the lanes is like one hard thing. And then you go to the state machine side and then you use that information and you stay between them. But getting computer vision to work is obviously really important. And last, data acquisition. That's just what I said earlier about getting data from all of the sensors. That's kind of tied in with the EE team, but the CS team does that as well because it's important for all of our coding to know like what kind of data are we getting and what are we going to do with it. Any questions? I know I went kind of quick, but any questions? Yeah, Sindel just linked the YouTube channel, so if you wanna go there, you can see all of the workshops that we've done so far. We have the Arduino ones for the CS team and some SolidWorks ones from the ME team, and Gary has done one on motors as well.
All right. Yeah, that was just like some of our subdivisions that we have. Now on to like kind of like the important business, which are our plans for the rest of the year. Obviously, as Tim mentioned, we kind of have to redesign some things to work with like our one battery platform. So honestly, we're gonna work according to the parts that we currently have right now. But if we do need to buy some, I mean, there's always that route as well. We're trying to stay away from that, but I mean, if we need to help complete the build, that's totally fine. As well as we have to go back into the testing phase. I think redesigning it won't take us that much more time, but another thing that's kind of holding us back is us like acquiring the parts from the school. So we kind of have to work around that too. I mean, we're gonna be able to get them, but in terms of like the date on when we are, it's kind of tricky right now based off like the current situation and like policies the school has. But we are gonna get these parts out, so just want to throw that out there. Yeah, we have to. I mean, in terms of redesigning, it has to go with having the actual robot ready for the competition. So we don't compete this year. There's always next year, but we'll already have that like part functioning. So I don't think that's like our biggest concern right now. Our main thing just this year is just having the robot built and up and running and troubleshooting and just all that good stuff. So in terms of competing, I don't really want to like focus too much on that. I want to actually like build it because we're already like a year in. So I think we're in a good level. I think we have more than enough like capabilities and like people with the proper skill sets to have this done. So I really don't see us like kind of like being stuck. If it wasn't for quarantine, would have been probably made it a lot farther, but it is what it is right now. I don't know if anyone has any questions for me. So yeah, in terms of that was like all the kind of information we had for this meeting. I don't know. Do any of the members have any other questions in general, or like in terms of the slides or the work that we might be doing this year? Well, this semester.
Just to ask, I was talking to Tim a couple of days ago. I heard we weren't using the suspension anymore.
Yeah, I mean, in terms of that, I mean, that one's still kind of up in the air. That kind of falls within like the testing aspect of it. Like I was telling Tim, like if we don't really need it that much, based off like kind of like the analysis that we're gonna make, there's really no point into adding it. But once we actually have like the parts back in our hands, we'll get a better sense of it. Right now, it's like a lot of us, we kind of remember like what we had in the lab, but it's been a good while since we've actually kind of like physically touched it or been around like these parts, because we left off like right during the testing stage. So there was a lot of things we kind of saw that we wanted to change, but it was like a last minute thing where everybody kind of had to like evacuate. So in terms of remembering that, it's been since like March that we have to remember parts. It's a good while. So I think that's where we kind of left off. We didn't test it with the suspension, but from the looks of it, I don't really think we needed one. So just to answer your question right there, Joseph. But yeah. Um, any other questions? Do you guys know like what sub teams you guys would want to be a part of? I mean, or like a general sense of it?
I'm feeling, of course, mechanical or maybe even electrical if I have the courage for it. I don't know.
You should try both.
Oh
See
man,
if you like it.
and the time permits, but yeah.
If there's a job open on CS or EE, I can do a task.
I mean, I can't tell you how happy that makes Gary, but they definitely need some help on the EE team. Honestly, yeah, like I would preach like going to the EE or the CS team because eventually, like once all our tasks for the mechanical team are done, we're all gonna have to switch to the CS team for the most
Yeah.
part. So it's like I don't want you guys to think that just because you're an Emmy, like we're gonna stay here forever. Like once we're done with this work, it's all to the CS aspect of it because that's the main component of this competition.
How much I'm sorry.
Go ahead, no.
How much self-teaching would it take for EE? I want to do like power distribution.
Well, Gary's currently like working on that, so it's a good amount. But I think like the best thing you can do is one, kind of look around and do research on your own, but also reach out to professors. A lot of these professors are willing to help you. Like the competition is neat in itself, so a lot of professors don't they don't mind helping you. So I would always say if you're stuck on something and we can't help you with it, just reach out to a professor. I mean, it's your best kind of like scenario to follow. So
Thank you so
yeah,
much.
don't be discouraged. Don't know. A lot of these things they're self-taught. Like the whole CS team, a lot of it is self-taught. So it's just you just kind of have to find that time and start digging into it. This competition it is far from easy. I'll tell you that. It's far from easy. So, but we have a good support system. I mean, so I wouldn't want to get too discouraged like that. But there's a lot of interesting kind of parts to it. Aside from the ME's team, but yeah.
And fellow ASME members, remember we're also doing workshops every Friday. Each of the team leads, or well, the majority of the team leads are definitely going to teach something in their own team. Like for example, last week Aaron's team, which is CS, they were doing some like cool Arduino coding, all that stuff. Oh no, yeah, Arduino coding. This semester is mostly going to be a learning experience. We will assign you all tasks, but we're definitely going to help you guys out. At least learn the basics of each team, what to do. So if you guys, like for any freshmen in the room, if you guys don't think you guys have that much experience with all this stuff, don't worry. It's all cool. We're going to help you out, all the team leads, and especially the workshops. Yeah, I remember when I was a freshman last year, I had no idea how to do all this robot stuff. I mean, I had a little experience, but it was like screwing in a screw, you know. But I was part of the E team, and I gotta say, the previous lead really helped me out. I didn't know that much about Arduino coding until I learned it from him. And like encoders, I had no idea what that was. It was so cool. It's like sort of like the detection of how much of RPM there is in an actual rotating wheel. You know, they're definitely going to teach you up. They're definitely going to teach you. This is a pretty groovy club, and we're definitely going to enhance your skills.
And to add to that, I think this club, like the competition itself, just helps you not only learn a lot, but it allows you to work in a team. And honestly, you kind of work with like all walks of life. So I think that's the best way I can put it. So I mean, just working in a team is probably an important trait that like a classroom doesn't teach you. So that's one thing. And then another thing is if we do like this competition right, I mean, that'll just open up opportunities for one, like the club, two, yourself, and three, like the school. I mean, we've never really done something to this scale in terms of autonomous systems, like aside from like RoboSub, but this one's like land-based. So in terms of like something like that, we've never really done it. And one that's it's already made into a senior design project. So like the future of autonomous systems is like up and coming. So I mean, there's that. That's another kind of one thing. It's a neat experience, is what I'm trying to say. Yeah, so there's that. I mean, for like this meeting, we didn't want to like break. We just kind of wanted to expose the new members and like returning members to like the sub teams that we have. In terms of next week, like obviously we'll break down into like sub teams and start like giving you guys like minor tasks, just so you guys can start getting like familiar with like what we actually do. But in terms of this one, we're just gonna keep it kind of light. I just wanted a lot of you guys to get exposed to what we do, understand like the concept of like this competition, and try to see where you guys want to fall within. There's a lot of neat things, like I've said, and it'll get a lot more interesting once we actually have the parts. I think that's the only thing that's kind of like holding us back. But if we had the parts, I think we would be a lot more farther than we are right now. So just cross your fingers, and we're hoping for the best right now. Yeah, everyone's kind of quiet today. Is you guys don't have any other questions, like overall questions? I don't know. You guys tired or shy?
Pretty tired.
Or stress.
Yeah.
Midterms, dude.
Physics too.
No worries. I just kind of I mean, if there's really no other questions, I think that's all we had for today. Yeah, we wanted to keep it light, so there's that. But something else I want to tell you, we'll be having these meetings weekly. So at the same time, and then we'll just start assigning tasks like as the meetings kind of progress. But one thing I do want to emphasize is, if you guys are kind of like new, I would say attend these workshops or like watch them on your own time, because they have some fundamentals that are important. So we don't want you guys to be lost throughout like the actual process. But yeah, I don't know if anyone else had anything to add to it.
I think that was mainly it. But I do want to share some insight on why I kind of want to push the ME team to join the other teams as well. So I've been I've been a part of ASME for 3+ years now, and I've never really touched the other teams besides ME. And I've kind of like, not really regret it, but just I think it's a good idea to join the other team so you could get like so you can understand how that plays into the ME team as well, because the ME team is not just build and, well, okay, technically it is build and like analyze, but there's some like constraints, like we have to work with the EE team as well, because they work on motors and batteries, and that kind of plays into how you put into how you build the chassis. So it's like a back and forth kind of thing. So if you kind of like understand each other's tasks, it's like it'll make you a better engineer, I guess. So I just want to put that out there.
Yeah, and to like Tim's point, like if you just stay like mechanical, yeah, you'll have a chassis, but do you know how to run the motors? Like, are you gonna know how to make them work? So I mean, just that type of experience. I mean, it's better to kind of like familiarize yourself with all these other sub teams, because it'll just make you more well-rounded, and I mean, you'll just become stronger. So there's that.
I was gonna say, for the CS team side, if for those of you that have been like already watched the workshops or already know everything that I was talking about, and you want to get started on the higher level stuff, especially if you're like a first year or a second year and your classes are like more light, so you have some extra free time, you can definitely like just send me some message on Discord, and I can give you any sort of task to do. I could get you started on ROS if you already have Ubuntu. I could give you another Arduino task or some sort of like little project on Arduino if you want to get better at that. But there's plenty of things you can do if you're bored or if you have free time or anything like that. But if not, just workshops are a great way to catch up as well.
Yeah. For the most part, fall is just gonna be a lot of like preparation and like kind of like that back end work. Where we're actually gonna get into like building, testing, and troubleshooting is spring. So that's why we kind of want to like get everyone on the same page, up to speed on what we do, and just understand like the fundamentals. Because once you reach senior design, you should know all these fundamentals. Like it'll just make your experience that much better. So that's another thing why joining early on is important. Why competitions like these are important. So just try to make the most out of it. We have a strong group, and hopefully, I mean this year kind of clears up so we can compete in June. Hopefully, crossing my fingers. But yeah, that's the goal. Have it done and possibly compete. So just want to throw that out there. But yeah, in terms of if nobody has any other questions, I mean, I think we can end the meeting here. But when you guys do have time, can you guys fill out like the membership application? Just it kind of gives us a better idea of like what sub teams you guys are a part of, and it helps us track like who was a part of the club this year. You know, 'cause everything's always changing, so we kind of want to catalog that. So
You're
yeah, I'd
talking
appreciate
about
that.
the form?
Yeah, the form, the one-page one.
Sure, right there. That's for people that haven't filled it out already.
All right, cool. Yeah, Orange just dropped it in the chat. But yeah, if you guys have any other questions, you guys can always just email us.
Just in case anybody's not in the Discord as well, that's the link.
Oh, okay, yeah, we have a Discord. Yeah, we're working on a website currently. It's gonna have like all our material, all our content. So just kind of stay on the lookout for that. That's another kind of like source of work that we want to put out to our members. And yeah, so I'll just keep you guys updated as we go in these meetings. When we get the parts, when we get new parts. We already ordered a bunch of parts for this semester. So we're just kind of waiting to see how we're gonna like get everyone involved. But next week we'll definitely have tasks for each sub team. We'll break into sub teams and then just assign some of these tasks, just so we could start getting like some kind of like feedback from you guys. See if you guys need to work a little closer with you guys. But yeah, for the most part, feel free to reach out to any of us. I mean, we're always open to help. So I want to thank everybody for coming. I know it's kind of in the afternoon, but thank you. I appreciate the time, and let's just have a good year this year. So let's get it done.
Cheers.
Thank you for coming, everybody. Have a good day. Enjoy it.
See y'all.
See you.
See ya.
Thank you.
Later.
Bye,
Good
guys.
luck. Good luck in midterms.
Yeah, good luck on your
Right
midterms,
back at you,
everybody.
Abel.
Get those A++s, you know?
Physics 2.
Oh, but yeah.
Aim
Yeah.
for that B+.
See everyone on Wednesday. Next Wednesday.
All right, see you guys.
Yep. See you guys.
Take it
See
easy,
you guys.
everyone.